Hello, welcome to the notes for completing angle pairs. During this video, you may pause it at any time or rewind it in order to complete the notes on your handout. When you complete the notes, please show it to the substitute in order to get your worksheet for this particular lesson. The worksheet will be due tomorrow. If you do not complete the notes before the end of the bell, be sure to pick up a worksheet. When I return, I will be checking both the worksheet and the notes. You must have both. There are many angle pairs that are useful for us in geometry that we can apply to find the measure of various angles. The first type of angle that is helpful is something we call adjacent angles. These are two coplanar angles that have a common side, a common vertex, and no common interior points. In the diagrams below, angle 1 and angle 2 are coplanar angles. They're on the same plane. They have the common side, this side right here, and a common vertex right at this point. So they are coplanar, no common interior. Here's the interior of 1. Here's the interior of 2. They have nothing in common. So angle 1 and angle 2 are adjacent angles. For the same reason, angle 3 and angle 4 are also adjacent. Remember, you can pause in order to complete notes. Once you are done, unpause and advance. Another type of angle that is helpful are vertical angles. Vertical angles are pretty common. There are two angles whose sides form opposite rays. In this diagram, there are two sets of vertical angles, angle 1 and angle 2. The sides of angle 1 are here. The sides of angle 2 are here. And those sides, notice a side from angle 1 and a side from angle 2 make opposite rays, also known as a line. Angle 3 and angle 4 are also vertical angles. Vertical angles are always going to be formed when two lines intersect, as in the diagram. The key information about vertical angles is vertical angles will always be congruent. And again, congruent means the same size. So angle 1, angle 2 are congruent, which means they have the same measure. If angle 1 is 70 degrees, angle 2 also has to be 70 because they're vertical. Make sure that we are talking about two lines intersecting. A common error would be one line the other not quite a line. In this case, angle 5 and angle 6, they are not vertical because they were not two intersecting lines. Our next type of angle are complementary angles. These are two angles whose measures have a sum of 90. Each angle would be called the complement of the other angle. So the complement of a 20-degree angle would be a 70-degree angle. The complement of a 50-degree angle would be a 40-degree angle. Diagrams that show complements. Here, angle A and angle B are complements because 47 plus 43 equals 90. And in the other picture, angle 1 and angle 2 are complements. Here, we're using the fact that angle 1 and angle 2, because they're adjacent, we can add them together. And notice that they add together to equal this right angle. The little square represents a right angle. So angle 1 and angle 2 make up a right angle, so they have to add to equal 90 degrees. The next type, supplementary angles. Two angles whose measures sum to equal 180 degrees. Each of those angles would be called the supplement of each other. So as with complementary, we have two different situations. The two angles don't have to touch at all, like angle B and angle C. Those two angles add to equal 180 degrees, 137 plus 43. And angle 3 and angle 4. Angle 3 and angle 4 are also adjacent. Notice we have the common side. And their other two sides make a line. So those two have to add up to equal the total number of degrees in a line. And remember, that's a straight angle, 180 degrees. So angle 3, measure of angle 3 plus the measure of angle 4 is 180 because it made a line. So that causes us to name them as supplementary angles. They are supplements of each other. Remember to pause as you need it. Things we can gather from diagrams, and more specifically from unmarked diagrams. Diagrams that don't have any congruence marks or any right angle marks. What kind of information can we gather from those? Well, we can always identify adjacent angles because in the picture we can see that they share a side, share a common vertex, and no interior points in common. We can also identify angles that are adjacent and supplementary in a diagram such as this. They're adjacent because they share this side, and they're supplementary because they make a line. That can be a known fact for us simply by looking at the diagram that has no other markings on it, no congruent symbols, no right angles. We could also identify vertical angles. Remember, anytime two lines cross, there are always going to be vertical angles. So in this picture, 5 and 6 would be two vertical angles, and the other two angles would be vertical as well. And there are some things that we cannot conclude from a picture that has no markings on it. Again, if it has congruent marks, you know about congruence. But here we're talking about pictures that have nothing marked. We already established the things that we are allowed to conclude. We cannot conclude that two angles or segments are congruent. Just because they look to be congruent, that doesn't mean they are congruent. They would have to be marked for us to say they're congruent. The only type of angles that we can do that with are the vertical angles. Vertical angles are always congruent, and they're always created by two intersecting lines. We cannot conclude that an angle is a right angle. Just because it looks like a right angle does not mean it is a right angle. And the third thing at this point that we cannot conclude, we cannot say two angles are supplementary. Just because they look like they're supplementary doesn't make them. Now notice up above, If we have other information like they're adjacent, then we can talk about them being supplementary. But if they're not adjacent, we cannot talk about two angles being supplementary. Our last special type of angles are what we call a linear pair. A linear pair of adjacent angles whose uncommon sides are opposite rays. So I have adjacent angles, so they have to share a side. So here the two share side BD, and the two remaining sides are creating a line. So angle ABD and angle DBC are a linear pair. Now, linear pairs can be identified without markings again. They have that adjacent side, which we can tell, and they have the line ABC. So they are adjacent to each other, and their uncommon sides make opposite rays, which is also called a line. So these two are a linear pair. Now, linear pairs and vertical angles are very important to us. They give us information without having any markings. Vertical angles are always congruent. Linear pairs. If two angles are a linear pair, then they are supplementary to each other. Remember, supplementary means they add to equal 180 degrees. So in this diagram, angle KPL and angle JPL are a linear pair. They share side PL, and their other two sides form line KJ. So that means the measure of angle KPL plus the measure of angle JPL would equal 180 degrees. Because if they're a linear pair, they have to be supplementary. KPL is 2x 24. JPL is 4x plus 36. On the left side, combine the like terms. 2x and 4x is 6x. 24 and 36 is 60. Subtract 60. Divide by the 6. X is 20. So 2 times 20 plus 24 makes 64 for this angle. And 4 times 20 plus 36. See, 80 plus 36 is 116. And so the two angles would be 64 and 116. Remember to pause here if you don't have everything copied. The final angle information is we get a pair of angles formed by an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So in this picture, AY is the angle bisector. And anytime we're told something is an angle bisector, it makes two congruent angles, two angles that are congruent to each other. If we're told something is an angle bisector, right from that, we can conclude that the two angles created are congruent to each other. Let's look at a couple situations. Ray BD bisects angle ABC. Solve for x and then find the measure of angle ABC. They give us the information that the measure of angle ABD is 5x. The measure of angle DBC is 3x plus 10. So let's draw a diagram to help us visualize. We have an angle. The vertex of the angle is B. The two sides are A and C. BD bisects it, so D is going to be out in here somewhere. Here's D. And these two are congruent to each other. ABD, start at A, go to B, up to D. This angle in here is 5x. The other angle, DBC, DBC, is 3x plus 10. Because it was a bisector, these two have to equal each other. So 5x equals 3x plus 10. Variable on both sides of the problem, eliminate one of the variables. I'm going to eliminate it from the right side. That way my variable is on the left and my number is on the right. So 2x equals 10, x equals 5. So they want us to solve for x. We've done that. Now to find ABC. Well, ABC is the large angle. For us to find out the value of ABC, we need to plug 5 in for x. So this angle is 25. Since it's a bisector, both angles are the same. So this one's 25. And 25 plus 25 means the measure of angle ABC would be 50. And finally, the measure of one angle is 20 less than the measure of its complement. Find the measure of each angle. So we have an unknown angle, and we have the other angle, which is called its complement. Now they say this angle is 20 less than the complement. So they're relating the angle to the complement. So we know what the complement is. The angle is going to be 20 less than it. Unfortunately, we don't know the complement, so we could call it x. That would force our angle to be x minus 20. These two expressions would represent our angle, x minus 20, and the complement angle, x. Now, since they are complements, our angle and its complement have to add to equal 90. The equation would simplify to 2x minus 20 equals 90. 2x equals 110. X equals 55. So the complement is x, so it would be 55. Our angle would be x minus 20, so 55 minus 20 is 35. And these two add to equal 90. So we are confident that we found the angle, 35, and its complement, 55. At this time, with your notes complete, please share with the sub to receive your packet.